All right, we've been solving systems of equations using a variety of methods. We've used elimination, we've used graphing, and today we are going to be using substitution. Substitution is a bit of a different method. Now, definitely use this video while you were doing the homework. We're going to be doing half your homework problems in this video. We're going to have 6 homework problems. We're doing 3 of them here. So follow along and do your work with the video. That way you only have 3 problems to do when this is done. And that's a lot easier than having to do 6 of them. And plus, as I said, this is kind of new for you. Make sure you're getting some practice along with me before you try it on your own. So I have the steps written out over here, and we're going to use these steps each time we solve the problem. Now, when you're solving a system using substitution, first step you want to do is isolate one of the variables in one equation. Now, you're going to notice that in all these equations, one of the variables is already isolated for you. We did that on purpose. Y is isolated for you in number 1, because you'll notice it says y equals 6x minus 11. That's what we mean by isolate. So one of the variables is alone. It's not always going to be y. Sometimes it could be x. I think in a lot of these cases we're going to have y today, though. If you look at number 3, again, it ends up being y. Why? Who knows? And then number 5, well, this is an easy one. Y equals 2. We like that. Or negative 2. So you notice that step 1 is done for us in each of these problems. Step 2 is you're going to substitute the variable's value or the expression into the other equation. Then we solve for the variable that isn't defined, and then we substitute the new variable value into any of the equations. So I'll show you what I mean. So step 1's already done here. So I'm going to rewrite my equation here. Make sure you're getting your signs correct. If you make a sign mistake, it's really easy to go off into a different tangent. You don't want to do that. All right, so you notice I have negative 2x minus 3y equals negative 7. Now, within this problem, I have a value for y. They tell me here y equals 6x minus 11. So where I see y right here, I'm going to substitute it in with this expression, 6x minus 11. So I get negative 2x. I'm rewriting it. Always rewrite it. 3, and then times 6x minus 11 equals negative 7. So it's a little tricky concept here, but if you notice, I had y isolated, y equaled something. I took what y equaled, and I plugged it in for y into the second equation. And now I'm going to solve. So let's see, I'm just going to shrink this down, don't mind me. I think I'll do this in a different color too. Alright, so now I'm going to have to use the distributive property. You're going to use that a lot today. So watch out for mistakes. I get negative 2x, nothing changes here. Now, I get negative 3 times 6x and times negative 11. Negative 3 times 6x gives me negative 18. The negative times the positive gives me a negative. And then negative 3 times negative 11, a negative times a negative gives me a positive value, 33, equals negative 7. The next step, I'm going to combine my like terms. I have negative 2x and negative 18x. When you take two negatives and you're putting them together, right? That doesn't make a positive. It only happens with multiplication. If you're combining them, then they still stay negative. So negative 2x and negative 18x gives me negative 20x plus 33 equals negative 7. I'm almost done. Well, I'm getting there. You're going to see there's another step or two involved. But all right, so now I'm going to subtract 33 from each side. Undo addition with subtraction. Negative 20x equals negative 40, because negative 7 minus 33 gives me negative 40. Divide by negative 20 on each side, and I get x equals 2. You might think, oh wow, I'm already done. Not quite. Now you know what x is, right? We know what x equals. We still have to figure out what y equals. We just have an expression for y. So what I'm going to do is, let's see, I've substituted the variable's value and I've solved for that undefined variable. I've solved for x. That x right here, I've solved for that. I've got x equals 2. I'm going to take that, I'm going to plug it into one of the 2 equations I started with. So I started with these 2 equations. I'm going to plug it into the first one. Why? Because it looks like it's a little bit easier. It looks like it's a bit more manageable. Just plugging in Let's see, because now I have x equals 2, I can just plug in 2 for x. Whereas if I did it up here, then I'd still have to deal with y, and there's a lot more values. I figured go with the easy one, right? So let's plug it in. Y equals 6 times 2 minus 11. 6 times 2 gives me 12. Minus 11, y equals 1. And I finished. I have my values. I've got x equals 2, y equals 1. So like when you're solving for using elimination and when you're using graphing, you get an x value and a y value. So I can write that as an ordered pair. X, y. So there you go. I just did number 1 for you. Again, these can be a bit tricky, so make sure you're following along. We're going to do the next one now, number 3. Alright, so I have y isolated already, and I have a second equation down below. I'm going to write that out. 5x minus 4y equals negative 3. I know y equals negative 3x plus 5. So when I see y in this equation, instead of writing y, I'm going to write negative 3x plus 5. Again, because I'm using this second equation, I'm plugging in that y value. Y is going to be this. Alright, now I'm going to use the distributive property again. Before I do that, just want to take note, I have negative 4 in the front here. So negative 4 times negative 3 gives me positive 12x. Negative 4 times positive 5 gives me negative 20. And realize I am writing my equation again. I'm rewriting it. Always rewrite it. Don't just do stuff in your head. That way if you make a mistake, it's easier to keep track of this stuff. All right, next step, I'm going to combine my like terms. Do I have any x's I can combine? I do. I get 5x and 12x. 5x plus 12x gives me 17x. I get 17x minus 20 equals negative 3. I'm going to add 20 to each side, get rid of that subtraction. I got 17x equals 17. Divide each side by 17, nice and easy. X equals 1. We've gotten some nice solutions so far. First one we had 2, this one we got 1. But I'm not done. Just because I've got an x value does not mean I'm ready to pack it in. I got to take that x value now and I got to plug it back in. I'm going to plug it into that first equation we had here. The y equals negative 3x plus 5. Why? Because the second equation's got more stuff going on. I get 5x minus 4y equals negative 3. A lot more going on. It's a lot easier to just take x and plug it in here. So that's what I'm going to do. I'm going to get y equals negative 3 times 1 plus 5. Negative 3 times positive 1 gives me negative 3. Again, you might be thinking, I can do this in my head. Write it out. It makes a difference. That way, if you make a mistake, we can always go back and say, oh, okay, here's where it was. Now, negative 3 plus positive 5 gives me positive 2. So now I've got an x and a y value. And because of that, I can write it as an ordered pair just like last time. So I'm going to write in 1 and 2. Notice I'm in pretty good shape here. I'm going to do number 6. I'm going to leave number 5 for you. But I'll give you a hint. When it comes to number 5, this one's a bit easier. I can even get you started on it. You have y equals 2, so I can rewrite my next equation, 4x minus 3. And instead of writing y, I'm going to put negative 2. And that gives me some work I can start with. So I've already substituted the y. That gets you started on number 5. I'm going to do number 6 for you, though. Number 6 is a bit tougher, so I'll do that one with you. All right, let's see if I have an isolated variable. I do. I've got y, and that equals 5x minus 7. That's really cool. So what I'm going to do is I'm going to rewrite my equation just like I have been. 3x minus 2y equals negative 12. Instead of that y, we'll replace it with what's up here. Negative 3x minus 2. Now instead of writing y, I know y equals 5x minus 7. So I'm going to write in 5x minus 7. And then that equals negative 12. Take a note, it's been happening a lot. Again, negative value right in front of my parentheses. So be careful. Common mistake. Let's see. So I get negative 3x. Negative 2 times 5x gives me negative 10x. Negative 2 times negative 7 gives me 14 plus 14. All right. Let's see. I'm just going to shrink some stuff down a little bit. Don't mind me. Looks a little messy at first, but it's going to come out nice and neat. Trust me. All right. First things first, I'm going to combine my like terms. Negative 3x, negative 10x. When you combine those negatives, you don't get a positive. Again, that only happens if you multiply. So if I do negative 3x and negative 10x, combine those, I get negative 13x plus 14 equals negative 12. Get rid of that 14 by subtracting on both sides. And I get negative 13x equals negative 26. I'm almost done. Since negative 13 is next to the x, remember it's a coefficient, that means multiplication's happening. I'm going to solve it by dividing. I get x equals 2. It's coming out pretty nicely. You're lucky. A lot of times you don't get 2 all the time or 1, but this is good. All right. So now I know what x equals. I'm going to plug it into that first equation. Why? Because I got less going on. But you really could do it at any of them. So now instead of x, I'm going to write 2 since I know that x equals 2. So I get y equals 5 times 2 minus 7. 5 times 2 gives me 10. 10 minus 7 gives me 3. So I am done. My final answer here is x equals 2, y equals 3. So using substitution can be a few steps. As you can see, it involves a lot of distributive property in some cases, and you're doing a lot of multi-step equations here. But it's a good method sometimes because sometimes elimination doesn't work out so well. And sometimes when you graph it, you're not always going to get a perfect solution. So substitution can be a good bet sometimes. So I did 1, 3, 6, and I even got you started on number 5. I covered these up, but you will be doing these, and I'll show you. Once you pull up your homework assignment, you're going to notice that you have these. And I just want to get rid of that. Come on. I don't want to copy. Anyway, here we go. That's what I want to do. Delete. Delete. So you got 2, 4, and you're going to be doing 5 for homework.